Installation, Setup, and Troubleshooting. Chapter 5. Proper installation is essential. It ensures your robot performs reliably and safely during its mission. We'll walk through the key steps of installing the hardware, configuring software, running initial tests, and handling common problems that may arise. By following these best practices, you'll reduce downtime and improve overall mission success. Let's begin by looking at the checklist you should complete before installation. Before working with your robot, especially during setup, maintenance, or sensor installation, there are a few critical safety rules you must follow to avoid damaging the system. First rule: never connect or disconnect any sensors while the robot is powered on. Second rule: never remove the battery while the robot is still powered on. This can cause data corruption, hardware failure, or system instability. Before operating your robot, start with a quick safety check. First, make sure the robot is in the crouched position, as shown in the image. This is the safest and most stable posture, reducing risk of sudden movement or drops. You'll use often in daily practice. Next, before powering on, take a moment to check the battery level to ensure you have enough power for the task. Then, set the robot into a crouched position. To protect the joints from overheating, avoid using advanced motions too often, like flips, handstands, or holding an erect stance for long periods. Power off the robot only after it's been lowered. Two factors that limit the robot: battery and joint overheating, which can cause the robot to stop working immediately. Before you start installing your robot, it's crucial to perform a pre-installation checklist. Review the user manual and safety guidelines carefully, especially the warnings and setup instructions. Verify that all components and accessories are included. Missing parts can delay the process or cause operational issues. Inspect the equipment for any visible damage and confirm that everything is compatible with your mission environment, including terrain, temperature, and weather conditions. Make sure power and network requirements are met, and that you have the right tools and safety gear on hand. Lastly, clear the installation area of any obstacles and secure any mounting fixtures. Now let's move on to the physical installation process. This training uses a quadruped robot as the reference model for demonstration purposes, but the same steps can be applied to other robot types. Make sure the robot is in a powered-off state and positioned in a stable, low-ground posture. Remember to follow the safe handling steps we covered earlier. Place the robot in a location where it can operate effectively. Secure any mounting brackets, clamps, or docking stations firmly to prevent unwanted shifting or vibrations during operation. When connecting cables, whether for power, data, or sensors, take care to verify that connectors are clean, undamaged, and tightly fastened. Install the battery or external power source carefully, following manufacturer guidelines. Double-check for correct polarity, solid fit, and secure attachment to avoid loose connections during movement. With hardware in place, it's time to configure the software. Start by installing any required firmware or control software on your computer or controller device. Connect the robot to your network or communication system, setting up Wi-Fi, Bluetooth, or radio links as needed. Next, calibrate critical sensors and actuators. This may include cameras, LiDAR, gyroscopes, or motor encoders. Calibration ensures that sensor readings and movements are accurate and reliable. Follow on-screen instructions carefully and save all configuration settings before moving on. After completing the setup, run a full system test to verify everything is working correctly. Begin with hardware diagnostics to confirm sensors, motors, and power systems function as expected. Test communication links by sending control commands and receiving telemetry data. Check that mobility systems respond smoothly without unusual noises or delays. Observe sensor outputs for accuracy and consistency. If any issues are detected, return to previous steps to troubleshoot before proceeding. Successful testing ensures your robot is mission-ready and helps avoid failures in the field. Installing a LiDAR sensor on your robot is a critical step for enabling mapping, navigation, and obstacle detection, but it must be done carefully and precisely. Before starting, power off the robot completely and place it in a low-down, stable state to prevent any accidental movement during installation. Next, mount the LiDAR securely using the recommended brackets or screws. The sensor must be positioned level and flat, typically at the front or top of the robot, with a clear and unobstructed 360 degrees field of view. A tilted or loose mount will result in inaccurate mapping and unreliable obstacle detection. Now connect the power and data cables exactly as shown in the manufacturer's wiring diagram. Be cautious, double-check for correct polarity, and make sure all connectors are firm, clean, and undamaged to avoid short circuits or disconnection during movement. Once connected, verify communication with the robot's main controller. This might be through USB, UART, or Ethernet, depending on your system. Use the supplied software or SDK tools to confirm that the LiDAR is recognized and sending data properly. If required, calibrate the LiDAR for accurate measurements. This may involve entering the sensor's height, orientation, or mounting angle into the configuration software to align the scan data with the robot's frame of reference. Important safety note: avoid looking directly into the LiDAR beam. If it's a laser-based model, it can be harmful to your eyes. Once everything is properly installed, secured, and tested, power the robot back on and begin scanning or navigation routines confidently. Before operating any robot, it's important to follow a few basic safety precautions to ensure safe use for both people and equipment. First, always keep a safe distance from the robot during startup, shutdown, and motion transitions. Make sure no one is within at least a 1 to 2 meter radius during critical operations like standing up, jumping, or switching modes. Do not touch the robot while it's moving. Keep hands, fingers, and loose clothing away from joints and moving parts to avoid injury. Check your surroundings before triggering complex motions, such as jumps or high-speed movement, especially near people or fragile objects. Monitor battery levels regularly and avoid operating the robot for extended periods without checking power or thermal conditions. If your robot is rated for weather resistance, ensure all ports and battery compartments are sealed and dried before and after use in wet conditions. Finally, always review the user manual and safety guidelines specific to your robot model and never bypass built-in safety systems. Taking these precautions helps protect people, property, and your robot from avoidable risks. Prevention is better than cure. Regular maintenance keeps your robot in top condition and helps prevent unexpected issues. Always charge batteries fully and check their health before and after missions. Clean sensor lenses and moving parts gently to prevent dirt or debris buildup that can impair performance. Follow the manufacturer's recommended calibration schedule to maintain accuracy. Stay up to date with firmware and software updates. These often include important bug fixes and performance enhancements. Keeping a maintenance log is also helpful for tracking wear, predicting parts replacement, and planning service intervals. If the robot operates in harsh environments like rain, dust, or mud, clean it promptly afterward. Before cleaning, power off the robot. Use a soft, clean cloth. Avoid metal brushes or abrasive materials that can scratch sensors and surfaces. Pay special attention to multi-view cameras or LiDAR lenses, and ensure no water remains in joints or seams. After wiping, dry the robot thoroughly with a soft cloth, and use a fan or air gun to remove water trapped in gaps. For long-term storage, place the robot in a cool, dry area, away from direct sunlight, moisture, and corrosive conditions. Remove the battery pack if the robot will not be used for an extended period. Consistent care, proper cleaning, and safe storage will extend the life and reliability of your robot, keeping it mission-ready when you need it most. Additional tips: avoid extreme temperatures, overcharging, or letting the battery drain completely. Keep charge between 30 to 70% during long-term storage. Let's take a look at common problems and how to fix them. Why won't my robot power on? Check if the battery is charged and properly connected. Verify the power switch is turned on. Inspect power cables for damage or loose connections. Try using a different power source or charger. The robot is not responding to controls. What should I do? Confirm communication link. Wi-Fi, AP, Bluetooth, Ethernet cable is active and within range. Cable secure plug-in. Check your phone which connected to the correct Wi-Fi. PC set up the correct static IP address. Sensors are giving inaccurate or no readings. How can I fix this? Clean the sensor lenses or surfaces gently. Recalibrate the sensors using the provided software tools. Make sure sensors are securely connected to the robot. Replace faulty sensors if errors persist. The robot is having trouble moving or is stuck. What can I check? Check the indicator light at front. Hold the robot in power off. Reposition the robot and power on. Firmware or software update failed. What now? Wait a sufficient amount of time, even if the update shows as complete, until the robot automatically reboots on its own. Restart the robot and attempt the update again. Robot loses connection during operation. How can I improve this? Remove the USB drive, wireless mouse/keyboard adapter if you plug those in the robot's port. My robot overheats during operation. What should I do? Reposition before turn on. What if the robot behaves erratically or unpredictably? Reboot the robot in controller. Verify calibration of sensors and actuators. Check for software bugs or update to latest stable version. Reset robot to factory settings if necessary. If problems persist after basic troubleshooting, like repeated sensor or motor faults, it's time to contact technical support. For software issues, update failures, or anything requiring warranty service or replacement parts, expert help can save time and prevent further damage. Keep notes on the issue and what you've tried. This speeds up diagnosis and resolution. Don't wait, reach out if you're unsure. For assistance, contact Norsat support at www.norsat.com.